Hi! Today, we're going to talk about permutation with repetition. So the number of permutations of n objects where n1 are alike, n2 are alike, and nk are alike is given by this formula. N factorial over n1 factorial, n2 factorial, and so on up to nk factorial, where n are the total number of n objects. Our first illustrative example is, suppose there are 10 coins of which 5 are 1 peso coins, 3 are 5 peso coins, and 2 are 10 peso coins. How many permutations are there? So to solve for the number of permutations, we have here 10 factorial, which is the total number of coins, over 5 factorial, 3 factorial, and 2 factorial, where its denominator are the different types of coins. So this can be written also as 10 times 9 times 8 times 7 times 6 times 5 factorial. So we will end up to 5 factorial since we can now divide 5 factorial from its denominator. So 5 factorial times 3 factorial times 2 factorial. So we can now cancel it out. So this becomes 10 times 9 times 8 times 7 times 6 over 3 times 2 times 1 times 2 times 1. So the total number of permutation in different ways, we have 2,520 different ways. Our second illustrative example is, how many distinct permutations can be formed from all of the letters of each word? So we have first the parallel. So there are 8 letters in the word parallel with 3 L's, 2 A's, 1 P, 1 E, and 1 R. So to solve this, we have 8 factorial over 3 factorial and 2 factorial. Since 1 here can be counted from these numbers. Now to solve this, we have 8 times 7 and 6 times 5, 4, 3 factorial over 3 factorial times 2 times 1. So you cancel 3 factorial. This becomes 8 times 7 times 6 times 5 times 4 over 2 factorial over 2. Since 2 times 1 is 2. So will not include 1. So the answer is 3,360 different ways. The second word is the success. So there are 1, 2, 3, 4, 5, 6, 7. So there are 7 letters of the word success. 7 letters having 3 S, 1, 2, 2 C's, and 1 U, and 1 E. So to solve this, from the formula, we have 7 factorial over 3 factorial and 2 factorial. So we have 7 times 6 times 5, 4, 3 factorial over 3 factorial times 2 factorial. So 2 factorial here is 2 times 1. And then cancel 3. This becomes 7 times 6 times 5 times 4 over 2. So just have to multiply all the numerators divided by the denominator. So the answer is 420 different ways. For our third and last example, we have to find the number of distinguishable permutations of the digits of the number 348, 838. So there are 6 numbers having 3 8s, 2 3s, and 1 4. So to solve this, we have 6 factorial over 3 factorial and 2 factorial. So we can now have 6 times 5 times 4 times 3 factorial over 3 factorial and 2 factorial. So cancel 3 factorial. So this becomes now 6 times 5 times 4 over 2. So the answer is 60 different ways. So this ends my video presentation. I hope you learned something. Thanks for watching. Bye!